Hi, my name is Thomas. I'm the CTO of Spin Robotics, and this is the MoCAAS system and the final demonstrator in our ESMERA project. What we made is primarily for small and larger enterprises that want to assemble things with the parts with the threads. Sometimes in these industries we have the problem of the return of an investment in these kind of assemblies processes. So what we wanted to do here was actually to do a mobile platform that can be moved around different workstations. So maybe Monday, Tuesday you can use it at one workstation, and the rest of the week use it for another task at another workstation. The issue in this is that it has to be recalibrated to the workstation, and for that we use this camera. So we will really makes it possible to automate situations where the return of investment on one assembly task is actually not good enough, but by having a mobile platform with this system we actually enabled the business case and gets a good return of investment in most European countries. Our screwdriving tool that's partly developed in ESMERA together with some of the camera integration is now at the technology readiness level at 8, so it's ready for the market as intended in ESMERA. We started the project with drawings on and a concept on how we could do this, and in the ESMERA project we have had extra focus on the safety part, where we actually have developed a mechanical sled mechanism to turn off the robot if you get the hand underneath the robot or the tool. We started out in this ESMERA project by developing different sensor technologies. So we had capacitive sensors in this part of the screwdriving tool, but it turns out that the business case in putting in expensive sensors, a lot of sensors in the tool, will actually make the tool too expensive. So we found another methodology where we use a mechanical sled system and a safety sensor, which already are performance level D certified. So that was a good compromise of getting a safe system, but still having an attractive price on the tool. So in phase 1 of the ESMERA project we had a heavy focus on finalizing the screwdriving tool, and especially the safety part with this safety sensor and the sled mechanism. And in phase 2 we had a lot of focus on optimizing the process, so that included the screw insertion process that we optimized so it is faster. And we have also introduced a camera for work cell calibration and dynamic positioning. So the idea of this is that you're actually able to put some landmarks in your environment at your workstation, and then the mobile platform together with the tool can align to this. So it always can insert the holes, insert the adjustable feet correct. So one of the main challenges in this ESMERA project was to increase the flexibility of the system. We do this by introducing this mobile platform so you can actually move it between workstations, but also the easy way of using the robot. We integrated every control system in the UR cap and using the UR framework to make it easy to program the robot. We do this because we believe that Universal Robot is the most known collaborative robot, and a lot of people know how to program it. So by staying in this environment we make it easier for factory workers and production staff at the factory to actually set up and program this by themselves. In this way we can lower the financial barriers in order to automate, instead of having a lot of integration work in making a solution.
Starts by the camera finding this marker, and then the robot will pick up a screw and cover the screw with this protective shield, so that there's no danger when the screwdriving tool is moving around the workstation. Therefore it's collaborative. And then the screwdriving tool will move up to the first hole and insert the screw, and whilst the screw is being inserted, the protective cap will retract, thereby making it impossible to get your hand caught between or getting screwed in the...
This ESMERA project is originated from the challenge provider Arçelik in Turkey, who are sampling home appliances, for instance refrigerators, and the task is to insert these adjustable feet underneath the refrigerator. We use them at home to adjust if the refrigerator is a bit off, or the floor is not completely even. Yeah.
It's okay, we'll
if
cut
the
it
floor
out.
is completely even. Yeah. So we have tried to simulate the setup of the factory at Arçelik in Turkey, where we have a conveyor belt where the refrigerators is coming, and then we have this MoCAAS station that can be moved away from the workstation and moved back again, and then we have the flex feeder. For now in this project we have used a wooden plate with the right threads, but it could have been another refrigerator, a normal refrigerator instead. That doesn't make a huge difference. Yes. Okay, in this ESMERA project, it's a partnership between us, Spin Robotics, that develops end-of-arm tools for assembly processes, and the Danish robotic integrator, Pahama Production. Our Spin Robotics task have been mainly concerned about the tool and camera system, and the task of Pahama Production is mainly about the physical setup and the feeding system. To have the MoCAAS as an attractive solution for robot integrators and robot distributors, we needed to have a low cost. So the tool and the computer and everything is around 9,000 to 10,000 euros in sales.